so recording has started, and yeah, I'm just gonna pull up random equations I've got. The context has been separated from the problems. The physics has already been done. We're just showing we're just showing at this point how to manipulate symbols, because a lot of students seem to be struggling with the idea of solving systems of equations, which two equations, two unknowns, stuff that they've done in high school, but maybe they did it by solving maybe they did it with a bunch of numbers rather than symbols, and now that they get to college, they see the symbols, now they're very uncomfortable. So I realized that we just had this conversation, but I'm just sort of recording the mission statement for other students who are watching in the future. But with a problem like this, I think the setup here was that this value was 0, so we can just ignore it, like the v2 was 0, and t2 was equal to like t1 minus a second or something like that, right? So t1 and t2 are unknowns, but they're kind of the same unknown, so to speak, in that if you know one of them, you know the other. But I believe that what we were trying to find was it v1?
Yeah.
And t1 were our unknowns, whereas h was known, the height of a building. G is known as just gravitational constants. And yeah, I think that basically covers everything. So I'm just going to talk about how I would solve this. Let's call this equation A, let's call this equation B. For this particular set of equations, it's a little bit easier to solve than normal, because as it turns out, equation B will let you totally solve for t2. So let's do that, right? I'm just going to rewrite h is equal to 1/2 g t2 squared. And you remember I just sort of got rid of the negative signs on both sides because they cancel out. But at this point, if we're solving for t2, well, you just move this to the other side, right? This becomes 2h over g t2 squared is equal to t2 squared, which is the same as saying t2 is equal to the square root of 2h over g. So far, so good?
Yep.
Well, at this point, okay, so now we know what t2 is, and I think we said that t1 is just equal to, what was it? t2 plus a second, I guess? So that's going to be 2h over g plus a second. Why did I do s? Plus 1. And we refer back to the first equation where, okay, we know what t1 is at this point. We just want to solve for v1. So, okay, let's go plug that in. Excuse me. Minus h is equal to v1 t1 minus 1/2 g t1 squared. Well, nothing too mysterious. We just plug it right in. v1 root 2h over g plus 1 minus 1/2 g root 2h over g plus 1. And at this point, I would probably say just straight up start plugging things into calculators. Right? I would say plug this in.
Would the t be squared?
You're right, it is. Sorry, I forgot that little symbol. Good catch. But, at this point, you could manipulate it more symbolically, but we're getting so close to the home stretch that maybe you just start plugging things in. Right? And can I assume that a student would probably know what to do from here?
Yeah, I mean, you just solve.
Right? Like, this, all of this, just plug everything in and isolate v1, and voila, you're going to be done. So that's just a very primitive example of solving for a system of equations. Like I said, this one was a little bit easier than maybe your average one, because one of the equations, you could totally isolate one variable without even having to involve the other. So do you want to do another example where you can't isolate it quite as easily?
Yeah.
Okay. I'm digging through the problems that we were looking at yesterday to find a slightly harder example. XF and TF. Okay, I think I see another one. XF and TF. Sure. A slightly harder one where I think we had something like X was equal to V naught T. Maybe TF, I guess we'll call it. And XF. And XF minus 40 was equal to, I think it was like V of something else. Let's call it V1. Or I don't know, let's call it V bus or something. Of TF plus 1/2 ATF squared. And I'm not going to bother explaining the physics because that's the point of the other videos. This one is really just about solving systems of equations symbolically. But for this particular problem, we found that or just by the statement of the problem, this term was 0 because v bus was 0. So at this point, I think our unknowns, if I remember correctly, were x and t, and we just have to solve. So for something like this, what I would do is say, well, this one actually happens to be already kind of nicely isolated for us, right? So let's just go ahead and plug that right into the second equation. Plug equation A into equation B. And then what we get is v naught tf minus 40 is equal to 1/2 a tf squared. I believe acceleration was known, right? Yeah, I think it must have been known.
Yeah.
So at this point, it just turns into a equation that's quadratic in tf, the unknown. So the thing to do here is just to put everything on one side. It doesn't really matter which side you move it to, just choose either one. 1/2 a tf squared minus v naught tf plus 40. V naught t, yeah, and at this point, this is just a quadratic equation, right? This is a quadratic equation, so plug it into your favorite formula, the quadratic formula, and that's just minus b plus or minus the square root of b squared minus 4ac over 2a. And just figure out what these constants, what these coefficients are by looking at the terms in front of the t's, or the constant term, and yeah, that's just what the problem is.
Cool.
And remember, for quadratic problems, you will frequently get two solutions, and sometimes you just have to do a sanity check at the end to remind yourself which one is the reasonable one for the problem. So for a problem like catching the bus, right, if you end up with, I'm guessing what happens is you're going to end up with a positive time and a negative time. And it probably doesn't really make much sense that if you're trying to catch up with someone, you managed to catch up with them -4 seconds ago.
Yeah,
right?
yeah.
So use your real world
Logic.
judgment, so to speak.
Okay,
but I think that should cover basic problem solving. Really, I don't think I'm doing anything revolutionary here. It's something that fundamentally is taught in every high school curriculum. But I think going from high school to college, solving systems of equations, not with numbers, but with variables, tends to present students with a lot of discomfort. And I just want to help students sort of get over that sort of crutch of relying on numbers so that they can get to the real need of the physics and math more. Okay.